Thank you everybody to come here. És külön köszönöm a vidékről jött magyar kollégáknak, hogy feljöttek az esemény miatt. And now I continue. Our demonstration will have three different parts. In the first short part, I will show a German national research project, which is very similar to the Hungarian Nemzeti Laboratorium, which was supported by the Deutsche OTKA, Deutsche Forschungsgesellschaft, and I will demonstrate that how we cooperate with the Konstanz University Research Laboratory in this topic. The topic is the 2 or 3 dimensional or video quality assessment. So, we had different groups in different places with different topics. The main topics were models and measures, interaction, human-computer interaction, adaptive algorithms, mainly about control, and something about the applications. And the main core is the data we use for training and test and so on. And also another main point is the user testing. So first of all, we need data, then we need users for testing when we are speaking about the human-computer interaction. So some words about the participants: University of Stuttgart, University of Konstanz with 2 groups, University and Munich University. Is the topics list if somebody is interested. So, and now I show you the project which was the previous nomenclature. It was the models and measures. It is the group A. The leader was Dietmar Soper, as I was the co-PI as an invited professor. And what is important that this project long 3 times 4 years, which means that the first milestone after 4 years, there was a written and oral report in front of a committee, and there was a decision about going on or retained. And practically there was some groups left behind, but practically it was the first 4 years. There was a second 4 years. And presently there is a continuation of some groups, or group terminated because Professor Sauper went to pension. But the project was absolutely successful. So what we are speaking about, crowdsourcing. The basic of training is for crowdsourcing. I have a short question to András about the budget. Lehetséges crowdsourcing az intézetben? Jó. So crowdsourcing for training, that is some subjective evaluation. We collect the annotated dataset. We measure the visual quality with some measures. Then we make some benchmarks, and there is the improvement for the interaction. A general thing for programming for changing bitrate compression, that we are looking for the main areas like faces or some equipments on the image, and then the compression is strong, and other places the compression is smoothing somehow. Think that there is a football match, and the whole stadium is compressed with some measure, but the face and the ball are compressed much better with better quality. So it's the salience-driven compression that I'm speaking. But no, the next I demonstrate the result. It was the Constance image quality 10K, which means that we generated an annotated database for images and videos where we had more than 10,000 images from some millions. So it was the result of the crowdsourcing, and this result has been published in a journal with 500, more than 500 citations up to now, and in the conference with 400 citations in the last years. Okay, it's Hungarian. So the problem is that in image quality assessment, the deep learning is constrained because of we need a big amount of data. So if we have data, then we should be very careful that it is a perfect data. So this work was about that how to sort the good data, how to annotate this data by crowdsourcing, and finally to make a program which works better than any other image qualification software, and so it's a new solution also for this case. So that I told you that we have more than 10,000 high quality annotated images, and it was 1,400 crowdsourcing staff, and more than 1 million qualification attempt. So it is the concept 512 is a collection of features. It means that what was the methodology to sort the data and how to annotate the data, and the deep learning method as well to make the interpretation. So the resolution was this size. Okay, so finally it worked the best. Okay. And finally, we generated a new deep learning method, but here we should tell that you will see that there is no very big difference between the best methods. We generated a better method than any other that time, but the difference is not too big. Because in this case and in similar cases, not the structure of the evaluation is the most important, but the data. This whole procedure is controlled by the data and the data quality. So finding the best quality data is much more important than writing a neural network, what is better a little bit than the others. I should say one simple thing: if we use deep convolutional neural networks, then it means that we have layers of convolution. But from image processing, we know that in linear cases we can exchange the order of the layers, and we can group them in the different orders. So practically we can perturb the layers, and we must get the same result if there is no nonlinearity. So that is why there are several solutions for the same problem, and the main thing is the data origin. So what about the data generation? We were looking for the faces to get images with faces in the good places, and we use several quality indicators. brightness, colorfulness, and so on, and bitrate resolution and measure. And there was some content indicator. And what is important that you see that what is the different features distribution for the whole data set. So we forced to have an even distribution of the different features to generate that there is a big peak for some features in some places, and it makes some serious effect in the training. Also, you see here it is the blue or one. And another thing was not only the data, so we should find the good data, but the annotation crowdsourcing stuff. That there was a selection of the crowdsourcing stuff. So there was some quality measure, for example, from the coherence of the answers and so on, and there was a threshold at 70%. If the worker is below this, then we neglected the results. You see here the architecture for the mean opinion values. Okay, no, and some results. This color is our answer. So you see that using different measures or solution was the best or mostly the best. And if we make the different image sizes, also you see that it is the linear one. And we tested also different methods. Our method was practically the inception model. It was modified for this purpose, but it was not so new method. The environment of it was practically new. It was the concept 512, and also you see the results that it is the best as usual, and you see the predictions for the mean opinion measure and for the prediction, so measurement against the machine answer. You see that it's a new correlation, and if we test another database, that is a well-known live database, then the correlation is also good for this case as well. It's an interesting result that if we have the curve showing that using different number of contributors, the crowdsourcing workers, then and we have this level of the qualification result, then at 9 we have a cross point, which means practically that if we use our program for qualify the images and videos, the quality is the same if we select 9 different expert persons and we count the average. So this method was as good or better than 9 different people for testing. And now you see some low quality and high quality images. The problem is that in many cases, what is the high quality image? What does it mean? And maybe it's a low quality or high quality. You see that it's some interesting, nice image. So that is why this image and video assessment turned to the aesthetic measurements. So now the research is about to find the aesthetical features. And finally, I should say that in this literature, it's very important that if you publish something, you should make the results open for the programming and for the data. So anybody who download your program with your data could get the same result. There are several not well addressed results in the literature. Most of them is some misclassification, so they are not correct. In our case, it means that in the Constance group, a German PhD student wanted to publish a very good paper, and he was rejected by a sentence that in a second or third order journal somebody published something with better result. It was 1 year for this boy to prove that result is not valid. After it, he could publish the own result. Okay, thank you very much. And then Marcell is coming.
Okay, I'd like to welcome everyone. My name is Marcell Golarits, and I will present you downsampling LiDAR point clouds while maintaining detection efficiency. So now we are changing our domain from images to point clouds, especially to LiDAR point clouds. This is a follow-up project what Tamás presented earlier. So it is an international program with De Montfort University, founded by the Royal Society. So I will go into details. I will skip some slides because we are short on time. So first about our motivation. So we want to downsample LiDAR point clouds and maintain the detection, because this is what we consider as quality measurement, and other quality measures which we defined as objective one is the human readable, which means in sense of LiDAR point clouds that it's similar to the original point cloud, and it's not an exact compression because we are doing subsampling, but it in some sense is similar. So also compression rate is one of our objectives. And why we are doing this? We want to downsample LiDAR point clouds. Well, in the near future, we think there are more and more cars will appear with LiDAR sensors. And in the near future, maybe they will connected in some cloud, and we will process the data all together, and we want to remove the unnecessary points from the LiDAR measurements. Okay, so first of all, we created a test. Let's say a test database. So we used Kitty object detection database, which is a car equipped with Velodyne LiDAR cameras and GPS. So basically it's a multimodal database, but we're only using the LiDAR data to test different detection techniques. So we looked up the Kitty benchmark and found out that the point pillars is still the best in terms of speed. Here is the Kitty object detection database metrics. So we have detection, orientation, and 3D detection, which what I highlighted because this is the hardest one. We will see in the next slide. And also the detections are grouped in the base Kitty dataset to easy, moderate, and hard. And we are looking for objects, cars, cyclists, and pedestrians. So as I said, we found out that in runtime, still the point pillars network was the best. Few words about the point pillars. So it's basically a special voxelization, and after the voxelization we can create a feature map and then apply 2D convolutions. This is why it is running much faster than other 3D convolutions or etc. Okay, this is the detailed results of point pillars on Kitty dataset. Here I also highlighted the 3D detection rates, because that's what I will use in the further examples. So we tested. I tested point pillars against different downsampling methods. One of them is the random downsampling, which is very fast but not a strategic approach, and the other one is FPS, farthest point sampling, which is strategic but not as fast as random subsampling. And I will present you the detection results. I run the point pillars originally trained, so pre-trained point pillars on these subsampled LiDAR point clouds, and then I retrained the point pillars on each downsampled point cloud and also evaluated. So some examples how detection on Kitty point database looks like by point pillars. So these are the downsampling by 2 and 4, and random downsampling with retraining the point pillars, then farthest point downsampling, and then farthest point downsampling with retraining point pillars. And I went down to 1/16 of the original point cloud. Maybe you can also see how much more similar is the farthest point downsampling to the original LiDAR point cloud. And so here are the results of the downsampling. As you can see, the farthest point downsampling is much better, especially when we retrained it. Then I will go over there. So here I highlighted two very important numbers: the runtime of the farthest point downsampling and the runtime of the random downsampling. As you can see, the farthest point downsampling is very, very slow. So I will skip this. In this research project, our next step is to find a downsampling method. We plan to use deep learning based downsampling method, which is CASNet. It's a cascade attention based network, and we plan to downsample it with this technique. And right now our latest results, so we were able to combine these two neural network, and but we have right now some issues with the GPU memory. So as first step, we downsampled with random downsampling, and then applied this CASNet downsampling method, and it's you can see it with yellow. So this line. So we went down from half to 1/16, and I hope in the future we will able to achieve better results. But this is the current latest results, and the inference speed we also have place to improve. And thank you very much.